It moved faster than a person could run. That is the first thing to understand. A wave of industrial molasses, 2 stories tall, tore through a Boston neighborhood at 35 miles per hour. It crushed buildings, knocked a firehouse off its foundation, and pinned horses to the ground. 21 people died. 150 were injured. The year was 1919, and for decades, people treated it like a strange footnote, a disaster too odd to take seriously. But that is not quite right. The tank had been there for 3 years. It stood on Commercial Street in the North End, 50 feet tall, 90 feet wide, holding 2.3 million gallons of molasses. This was not syrup. It was industrial alcohol feedstock for the United States Industrial Alcohol Company, used to produce munitions in wartime. Demand was high, so the tank stayed full. Here is what nobody questioned at the time. The tank was built in 1915. Construction took 4 months. The man put in charge had no formal training in structural engineering. His name was Arthur Gell. He was an accountant. The company gave him the project because he was available. When the tank was finished, they filled it with water once, not to test its strength, but only to check for leaks. It leaked. They caulked the seams and painted the tank brown so the leaks would be harder to see. Residents in the North End reported that the tank groaned in cold weather. Children collected the molasses that seeped from the seams. Nobody at the company investigated the sounds. Nobody inspected the welds. There was no law in Massachusetts in 1915 that required them to. None. January 15th, 1919. The days before had been brutally cold. Temperatures near 2 degrees Fahrenheit, or -17 Celsius. Then the temperature rose sharply. By midday on the 15th, it had climbed above 40 degrees, a swing of nearly 40 degrees in less than 48 hours. The tank had just received a fresh shipment of 2.3 million gallons 2 days earlier. Cold molasses is dense and sluggish. Warming molasses expands. At 12:40 in the afternoon, a low rumbling moved through the North End. Then came a sound witnesses later described as a machine gun. That was the rivets. Thousands of square feet of riveted steel plate unzipped in seconds. The wave crested above 15 feet. 2 stories of industrial molasses rolled outward in every direction at once. It moved with the viscosity of cold tar. It did not splash. It pushed. A nearby elevated railway support bent under the pressure. The inspector on duty saw it and stopped the next inbound train. That single decision saved lives. The Purity Distilling Company immediately blamed anarchists. This was 1919, and Boston had seen anarchist bombings the year before. The company issued a statement within hours suggesting sabotage. Newspapers carried the claim, and for a while it held. But the lawsuit changed everything. 119 plaintiffs, 6 years of hearings, 20,000 pages of testimony. The case went to a court-appointed auditor named Hugh Ogden, a lawyer and a colonel who had served as a judge advocate in the First World War. He was not an engineer, but he ran the hearings like a systematic investigation. He brought in metallurgists and structural engineers. He had pieces of the tank tested independently. What the experts found was not one mistake. It was a system of neglect built into every layer of the tank. The steel plates were thinner than good practice required. The rivets were too few and too poor in quality. The design calculations had never properly accounted for the actual load. Molasses is denser than water, yet the tank had been sized as if it were not. No licensed structural engineer had ever reviewed the plans. Here is what Ogden concluded. The company knew the tank leaked. They knew residents had reported the groaning. They had received internal warnings about the structure, and they kept filling it anyway because the molasses had value, and emptying it would mean a financial loss. Ogden ruled against the company in 1925. The settlements totaled roughly $1 million. No one was ever criminally charged. The metallurgical picture matters. The steel was low in manganese, a composition that becomes brittle under cold stress. The rapid warming caused the molasses to expand. Fermentation inside the tank was also generating carbon dioxide, adding internal pressure. On January 15th, the tank was simultaneously managing thermal expansion, gas pressure, and structurally deficient walls. Any one of those problems alone might not have been enough. All three together, at 12:40 that afternoon, were. And here is the part that is often overlooked. The disaster produced something lasting. It produced building codes. Massachusetts passed new regulations requiring licensed structural engineers to certify large industrial vessels. That language, licensed, certify, structural, did not exist in state law before 1919. It does now. Every industrial tank built in Massachusetts after 1925 operates under standards that trace directly back to Commercial Street. The 21 people who died in the North End are the reason those standards exist. That is how engineering regulation often works, not through foresight, through catastrophe. A failure occurs. It is investigated. A cause and mechanism are identified. A standard is written. The standard becomes a requirement, and the requirement is applied to everything built afterward by people who will never know why it was necessary. The molasses was cleaned up over weeks. Firefighters used saltwater hoses. Workers spread sand. Some accounts say the harbor still smelled of it the following summer. Today, the site is a small public park. A modest plaque marks where the tank once stood. Most people who walk past it have no idea what happened there. The buildings that replace the ones destroyed look like every other building in the North End. There is a version of this story in which the tank never fails, where a licensed engineer reviews the calculations before construction, where the steel is specified correctly, where the welds are inspected in 1916 and the flaw is caught before it grows. In that version, 21 people go home on the afternoon of January 15th. That version was possible. It only required oversight that no one had the authority to demand. That is the nature of recovered disasters. They disappear into the city, into the code, into the standards that now specify wall thickness, weld inspection intervals, and the license required to hold 2 million gallons of anything. The disaster becomes invisible. The standard it left behind is not. You just do not know you are standing in it.